Welcome to the Spy Collection. My name is Anastasios, and for this episode we have a secure communications artifact from the United Kingdom, the Racal MA4014B, or as it was officially described in the British government, an encryption unit for very flexible and secure means of conveying confidential information. Racal started producing this cipher device for tactical communications around 1975. Tactical, in the domain of secure communications, means the transmitted information has to be secure for a short period of time, like hours to days. Basically, in order to avoid highly complex processes of configuring the crypto devices, tactical communications could be things like status reports, movements on a target, and other communications that will be useless within minutes or hours after their transmission. So even if an adversary is able to decrypt them after days or weeks of cryptanalytic efforts, they will have no real intelligence value. The MA4014B was used between the radio operator and the transceiver to encrypt and decrypt the signals respectively, and it was compatible with any HF or VHF communications equipment. A well-known combination was the MA1414B together with the Racal PRM4031 manpack radio. Apparently, this is where we'd plug the transceiver, and this indication here shows us its PTE, that is private. Private in Racal's context meant encrypted. This is the ground connector and the mode selector. It sets the device in a mode that it can receive unencrypted signals, and if a certain synchronization signal is detected, automatically switch to the encrypted mode. On the other hand, send enforces transmission in encrypted mode only. Audio 1 and 2 are unique since they use Racal's proprietary multi-purpose connector. This can be used to connect a handset like this one, or a battery charger or other Racal compatible equipment. This made it very versatile and user-friendly. And now on the code knobs. As you see from this white line, they are split to two groups. The first two go from 0 to 8, and the second group goes from 0 to 9. That gives us a total of 64,000 potential combinations. Those knobs are used to set the secret code so that the two or more MA4014B could communicate securely. In practice, those were agreed upon in a secure facility, like before an operation, along with secondary codes in case the first codes got compromised, and changed on a defined interval, like daily or after each operation. The device was using that code in its pseudo-random number generator, or PRNG, which was the heart of its time division scrambling algorithm. On a simplified version, here is how its crypto worked. First, it was converting the signal from analog to digital. It was using a ROM to temporarily store this in chunks of 416 milliseconds each. Those were referred to as words by Racal. Then it was dividing each word into 8 digitized 248-bit shift speech registers, meaning each segment was 52 milliseconds of audio signal. Remember how the code knobs were used to influence the PRNG? Well, here's where that PRNG comes into play. It was generating the rearrangement order based on a configured list of predefined options. The reason why this wasn't configurable by the user was that someone could mistakenly order the segments in a way that will make it easier to comprehend what's transmitted. For example, just reversing all of the segments order or something equally simple. This is why Racal had this embedded in the device's algorithm. However, there was a way to modify it, and we'll look into it. As per its technical manual, over 600,000 internally selectable code keys are available, each of which is programmed by up to 64,000 codes selectable by front panel switches. Thus, over 40 billion different programs are available. The resulting scrambled signal was stored in a ROM before going to the last stage, which was to convert it back to analog and send it to the transceiver for transmission. Clearly, on the receiving end, the reverse process was followed. And now it should be clearer why Racal said MA4014B was operating using a time division scrambling algorithm. Now, on the rear of the device, you see those clips. Those are for the battery attachment. Basically, it could be powered directly through the transceiver unit, or you could mount a battery pack that clips into those metal rods. And this red cross shows us where the battery connectors are located. Here and here. They have those protective screws in place when they are not being used. Next, this is the desiccator to protect its moisture-sensitive internal components, and those large screws are holding the external enclosure secure. Let's open it up to have a look. This is its fuse box and its color-coded plug and socket panel, the patch board. Previously we mentioned that there was a way to change the rearrangement of the scrambling. This patch board allowed technicians to change its code programming procedure, basically how the order of the scrambling happens. Internally, the MA4014B has a very interesting design to make maintenance easy. It's split into 4 boards, each one secured with different coded screws. The first board is this one, and here is how you can access it. This is the audio processing board, and on the inside you can see the power supply board. In a similar manner we can access the other 2 boards. Let's have a look. This is the board that performs the scrambling operations, and it's named by Racal as the program board, and the small is the logic board. Now let's put everything back together. In 1980, the Armies and Weapons Journal published volume 65, where it had an article about the ComGuard range, which also gives us another glimpse into the secret history of the MA4014B. As we're reading, Racal Datacom soon produced a line of encryption equipment designated the ComGuard range. The basis of the ComGuard range is the MA4014B audio encryption unit. This unit provides more than 40 billion different code combinations selectable through front panel switches and an internal patch board. For today's standard, this crypto could be trivially cracked even with the processing power of a modern mobile phone. However, for the 1970s, this was a strong encryption, and considering that it was designed for tactical secure communications, even more so. We don't know if this was also used by intelligence agencies outside of the military, but this was, and still is, A common practice, so it wouldn't be surprising if in the future it's revealed that this was also utilized for other espionage activities. However, all secure communication devices are one of the biggest secrets of nation states, and this is why, even for a device like this, the MA4014B, we have an extremely limited amount of information even decades after its production. Another interesting piece of history that we discovered during our research was this. It looks like in 1975 the Ministry of Defense of Saudi Arabia purchased MA4014B crypto devices from the United Kingdom, and it looks like they were referencing it with a name we saw in the Armies and Weapons Journal. They called it RACAL MA4014B ComGuard Voice Unit. Due to the secrecy around such devices, we were unable to uncover more parts of its history. If you are aware of more details, please let us know in the comments below. It is remarkable that a nearly 50-year-old, no longer used device still has so much mystery around its history. It's why we say that nothing is as it seems.